Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Miličić and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. On this particular occasion, we will try and tell you a bit about the current moment and future of RabbitMQ via an overview of its architecture, tools, and upcoming features. And as many of you will know, RabbitMQ is the single most widely used Erlang-based technology. We estimate there's over 35,000 production deployments of RabbitMQ globally. Now, as with any live event, please do excuse any technical issues we may face today, but to start telling you a bit about Erlang Solutions, we are a products and services orientated company fully devoted to the Erlang programming language and increasingly working with and providing expertise around Elixir as well. We started in 1999 and have since worked with organizations and individuals using Erlang. We help evolve the language and we support people and organizations using it. Now, today we have just over 100 people across our offices in London, Stockholm, Krakow, Budapest, Seattle, and Buenos Aires, and we work on projects across the globe. We have also started developing Erlang-based products, and some of those you've probably heard of. They include our Mongoose IM messaging platform, the React distributed database, Wombat OAM, which is our monitoring and management technology, as well as other solutions across Erlang problem areas. Now, I'm very pleased to say that our speaker today is Alvaro Videla, a RabbitMQ core developer with Pivotal and the co-author of RabbitMQ in Action. Please allow me to finish by saying you're very welcome to post questions throughout the duration of the webinar by using the chat facility on the webinar's interface. Our speaker Alvaro will then answer as many questions as time allows us at the end of the webinar. If any questions do go unanswered, you are very welcome to raise them using email and the following address, webinar@erlang-solutions.com. If you're interested in learning a bit more about RabbitMQ or wish to establish whether it could be a solution for the challenges your own business may be facing, then by all means feel free to contact me directly. My email address will be displayed in the final slide of the presentation we will share with you today. I would now like to hand over to Alvaro, who will be glad to start us off.
Welcome everyone to the webinar. The title, as you can see on the screen, is Improvements in RabbitMQ Performance and Future Directions. As Mladen just said, my name is Alvaro Videla and I work as a core developer for RabbitMQ. That's how you can find me online. I'm also on Twitter or Videla Alvaro on GitHub. And as Mladen said as well, I'm the co-author of the book RabbitMQ in Action. So to get into the webinar, let's first try to answer the question quickly about what is RabbitMQ, because perhaps some people don't know that yet or are not too familiarized with what RabbitMQ does. RabbitMQ was conceived as a multi-protocol messaging server, specifically an AMQP message broker. AMQP stands for Advanced Messaging Protocol. As many know, RabbitMQ is open source under the Mozilla public license, but what's more interesting in this area is that this year we moved finally from Mercurial and our own private repos, private that were public but still hosted by ourselves, to GitHub. So now, since early 2015, you can send pull requests and review and see and follow all the comments for issues on GitHub. So that's a nice improvement we have this year. RabbitMQ is polyglot in many senses, in the sense that you can connect to it from many languages, you can talk to it in many protocols, and you can extend RabbitMQ with any language that is supported by the Erlang virtual machine. For example, Elixir, that is quite popular these days. RabbitMQ is written in Erlang OTP. That's quite interesting because it allows the broker to not need to implement a lot of code that will be required to have a robust solution. And Erlang, besides the whole fault tolerance story that comes with the package, has a very good binary handling mechanism, which for a broker that implements many protocols, that's really helpful when working with the code. I say multi-protocol. We have basically, now that it's even Halloween arriving, we have the mustache that may fit your needs. One is NQP, the Advanced Messaging Queuing Protocol. That's the default one that comes with RabbitMQ, but over the years, we got support for more protocols. MQTT is one that is used for telemetry. It comes from IBM, but it's also an open protocol. And then Stomp. Stomp is a text-based protocol. It's very simple to parse and to generate, and we support that as well. And in the case of NQP, let's be clear, we support 1.0, 0.9.1, and 0.8. So there are many flavors of NQP for people that know that protocol. We support all those three. So 1.0 is also supported in RabbitMQ via a plugin. And speaking of plugins, we have this website called, this webpage, Community Plugins, because before RabbitMQ has always supported plugins, but before you have to build them by hand, which was quite difficult to do, to set up the whole development environment for RabbitMQ, for plugins and so on, and then to be able to run the plugins yourself. So since over a year, we have a page where we host plugins developed by the community, and where you can just get them and drag and drop them into your Rabbit installation to run these plugins. I say polyglot in the sense of what clients we support. We have clients for Java, Node.js, Erlang, PHP, Ruby, .NET, Haskell, Clojure, many more, Python, and so on. The main difference is that the Java client, the Erlang client, and the .NET client are officially supported, while the other clients have varying degrees of support. For example, I'm in charge of the PHP client. A former RabbitMQ core developer is in charge of the Node.js client. We have another core developer taking care of the Ruby clients, the Clojure client, and so on. So we can say that RabbitMQ is not only a well-used server, like Mladen said at the beginning. We also have all these clients in all these platforms, which have a lot of users testing them every day. And yeah, we even support COBOL. Not sure if you're laughing or crying at home, but I had the bad luck of making this joke in a conference where a COBOL company was the main sponsor, so I hope I'm not getting in trouble today. But yeah, there is COBOL support also for RabbitMQ, in case you need that. Is there anybody using RabbitMQ? Yes, we have many companies using RabbitMQ. These are just a few. Instagram, every time there is an image going through Instagram, a new image will go through RabbitMQ. Indeed.com uses Rabbit. Telefonica, which is a telco from Spain and Latin America, uses Rabbit. Mercado Libre is eBay for Latin America, again using RabbitMQ. The NHS in England, Mozilla. For example, recently we know that the New York Times is using RabbitMQ, and they have very good news for them when they move to the new architecture, this one called Fabric, because during launch day they had 500,000 users and the connection time remained quite low. Yeah, every time you connect to the New York Times, there are some live feeds and so on that are using RabbitMQ in the background, WebSockets and so on. Of course, Rabbit supports all these platforms. If you can run Erlang, you can probably run RabbitMQ on top of it. And I will do just a very quick demo of what RabbitMQ can do with what I call the RabbitMQ simulator. So in RabbitMQ and in any messaging platform, the idea is to have producers that are able to send data to consumers. In the MQP model of things, you publish messages to an exchange. Every time you send a message, whether it's physically to another person or online in a platform, you need an address. This address, in the case of MQP, are exchanges. So your producer will send messages to the exchange. As you can see, the messages in this case are dying at the exchange. That's why the reason here is because we don't have a queue that is bound to the exchange. Once we add a queue, the messages end up in the queue. They are queued there. And if I finally subscribe my consumer to the queue, it starts receiving messages. If I add another queue and I publish messages, RabbitMQ will send out messages to both queues and so on. Of course, I can have more than one consumer connected to a queue, and RabbitMQ will take care of doing some kind of round robin of messages to consumers. The key here to understand here is that the exchanges are kind of routing, they implement routing algorithms on how to route messages to queues, depending on routing keys, publishing keys, binding keys, and so on. I'm not going to go into that because I'm pretty sure you are not here today to listen about how this works. If you want to learn more about this, we have tutorials on the RabbitMQ website or on the book I showed before and so on, explaining how to publish messages into exchanges, how to get into queues depending to which algorithm you want to use, how to connect consumers to queues, and so on. That's basically those are the basics of how to use RabbitMQ, and you can learn them on the Rabbit website. So let's keep going with the presentation. And now, probably what you are here to listen to is about the performance improvement that we've been doing on the latest releases of RabbitMQ. What was the problem? Why did we start looking into what to improve and how in Rabbit? A customer or a user on the mailing list came with a question that he wanted to publish 5,000 messages per second. These messages were of 1 kilobyte each. There won't be no consumers online during 1 hour, so only publishers. And the idea was to be able to sustain this rate of publishes for 1 hour. This person complained that RabbitMQ was getting slow after some minutes of starting the test, and they needed this to run for at least 1 hour. The memory usage was not high enough to trigger some kind of high watermark problem in the Rabbit management system and so on. So it was quite frustrating and hard to understand why RabbitMQ was getting slow and behaving the way it was behaving. What you see on the screen is a command that we have on the RabbitMQ Java client, which is a tool to run benchmarks against RabbitMQ. In this case, I'm using an exchange called exchange name of type topic with a queue called queue name, sending messages which are persistent with a rate of 5,000 messages per second. The size of messages is 1,000 bytes, and there is only one publisher, sorry, and no consumers. So when I try to run this on my machine, first generation Retina Mac with SSDs, 16 gigs of RAM, and so on, I quickly discovered that in about a minute or so, performance will highly drop. Rabbit will literally crawl trying to accept messages. Publishers will be blocked, and then after 15-20 seconds, they will be unblocked, and they will keep running, publishing messages. So for me, this was quite bad because the queue in RabbitMQ stands for queuing. So having a queuing system that cannot queue messages is quite embarrassing. And as a core developer, for me, it was more than a reason to actually find out what was actually going on. So this is more of the description of the problem. What I discovered was that as soon as queue paging kicked in, performance dropped. For some reason, the algorithm inside RabbitMQ that decides when the queue has to page messages was doing that, and whenever this trigger the paging mechanism, performance will drop. So let's see what was there happening this huge drop in performance. I found out that here I need to explain internals of RabbitMQ. There were 3 big issues discovered along about a month of different kind of improvement done into RabbitMQ. The first one was the QIndex flash journal. I will explain soon what that is. Then there was another problem when messages were published into this QIndex. And finally, we discovered there were some memory leaks in the paging algorithm of RabbitMQ. So what is this QIndex and what is this QIndex journal? Each queue in Rabbit keeps an index of messages that are published to the queue, plus it tracks when a message is delivered to a consumer, it's tracked, the message sequence ID is tracked as a deliver, and whenever a consumer acts the message, it tells RabbitMQ that this message was successfully processed. Then RabbitMQ deletes this message from the index and from the message store. To give you more details, there is only one message store per broker, or actually two, one for transient messages and one for persistent messages. The idea of this message store is to not duplicate data. So whenever messages are sent to the message store, it will keep track of how many times a message is used in one queue or in 20 queues in order to not duplicate message contents. But on the case of the queue accepting messages, it's also tracked the sequences IDs to know where or which messages belong to this particular queue we are working right now, let's say. So we don't want to persist to disk every one of these actions, like there is a new publish, there is a new deliver, there is a new act. Each message will go through these 3 steps. The message is published into Rabbit, delivered to a consumer, act from a consumer. We don't want to do that. Let's say if I have 5,000 messages per second coming in and out of Rabbit, this will be 15,000 operations per second going to the file system. That's of course bad. So RabbitMQ in the index has a journal. This journal keeps track of this operation in a sparse array in Erlang. The sparse arrays in Erlang are normal arrays which have items tracked by sequence ID or by ID to value, like a key value store. But the cool thing of a sparse array in Erlang is that we can define what a null item is. So whenever an item is nulled, if we use the sparse operation in the array, like sparse, fold, all the iteration function that go over the array, when we do it with the sparse prefix, this means to avoid the null items in the array. So this simplifies programming in the sense that we can have, in a sequence ID, we first, of course, track a message published, then and deliver, and later an act. And when the act is tracked, we basically null that sequence ID. At some point, when this journal grows, this array starts growing in memory, we flash this journal to disk. And we track it then later in some index segments which are written on disk, this is the final index format that we want to keep track of. So again, we keep a journal of the operations as an array, trying to avoid going to the file system for all these things that are happening too many times per second. When this journal grows too much, we need to flash it to disk. This journal can have, by configuration, 55K entries on it, approximately, as you can see on the screen. And now we also reduce this default, and we let users change the default. But the problem we found with this implementation is that whenever we need to flash the journal to disk, we need to convert every entry on this journal into the binary format that is written to disk. And we discovered by using fprof, which is a profiler that comes with Erlang, that, yeah, of course, this entry to segment function was being called that many times, 65,000 times, every time the index was being flashed, which is obvious. If you have 65,000 entries on the journal, and they need to be converted to whatever binary format RabbitMQ keeps track of on the file system, This has to be done. There is no way to avoid that. What we did to improve this area was to actually keep a cache also as an sparse array of entry to segment values. So whenever we appended a publish, let's say, to the journal, we also convert in place the entry into whatever binary format RabbitMQ expects. Whenever this entry goes from publish to deliver, we will update this key on the journal and on this cache as the final binary format. And whenever there is an ACK, again, we will do whatever is needed to do for that situation. What happened is that when we flash the journal later, when Rabbit considers this journal needs to be flashed, whether because there is memory pressure or because we reach this 65,000 entries, it's just a matter of sending this whole array of binary data to the file system, which using the array API of this sparse arrays, is just calling the array to list, and this will just flash all this binary data to the file system. But there is a catch. When we do a to list call to the array, what happens with the null entries? I mean, are they specified in Erlang as an undefined value, as a null value? How does it happen? And the array to list, the sparse array has a cool thing. When you create a new array, you can specify what the default value is for blank elements. In this particular case of this cache, we specify this as a list, and the library, the standard library from Erlang, the priv library that writes to the file system, knows how to handle lists of binaries, of lists of binary, and so on. And when there is an empty element, an empty list, like you can see here, it's just ignored. So we don't even need to make RabbitMQ go with the sparse to list function, which is slower. We can just call to list. It will convert this array to a list of lists, and with blank elements being the empty list. So this is actually ignored by the driver that writes data to the file system. So by doing that, we prevented this whole loop of going through 65,000 entries and converting them to binaries by using this cache. Yes, of course, we are trading time for space. There are no escapes when programming, or you use more memory or more time at some point. We decide to use more memory whenever there is a new entry going into the journal. So that's how we improve the paging of this part of the index, at least. But there are more problems. Performance improved, yeah, but still too slow. RabbitMQ, since version 3.5.0, has a new feature which lets messages that are lower than this value you see on the screen, Q, index, embed message below. Whenever a message is lower than, in this case, 4 kilobytes, this message will be sent directly into the index. The point here is to avoid going even into the data store. But this presents problems. Because the problem that happens here when embedding messages into the index is that RabbitMQ, from time to time, when it does paging, it needs to decide where to write the message, either to the message store or to the Q index. RabbitMQ Q implements a sort of cache, an in-memory cache of messages that keeps track of all the publishes, all the new messages that you send into a particular queue. This in memory is just implemented using a queue data structure from Erlang, the standard queue that comes with Erlang when you install Erlang. And every new message that goes into a RabbitMQ queue will go actually to the end of one of these queues in the cache. The thing is, when Rabbit needs to page messages to this, we'll decide, okay, we have 100,000 messages in memory in this cache. We need to page 50,000. They need to be written either to the message store or to the queue index. So in the case of the queue index, also by using fprof, we discovered that publishing messages there was quite slow. And also, whenever we were marking a message as already delivered to a consumer, this was also doing a write to the index. But the part that handles delivers and acts already support batching on the queue index. So it was improving this area was whenever we are paging, let's say 50,000 messages, it was a matter of accumulating these delivers and acts that you can see on the screen and sending them all at the same time, which will create only, will call the library that writes to the file system only once and not 50,000 times. And the same when we publish things to the index. What we did was to have to add to the QIndex API a batch publish feature or functionality that allows to send all new messages into this batch, and whenever there are 20,000 messages on this batch or the queue index needs to be flashed and so on, this cache is written all at the same time. So again, instead of writing each publish one by one when we do paging, they are sent in batches to the file system. It all seems a bit obvious. Of course, you want to batch data when you write it to the file system, but yeah, it was not there, now it's there, and we know that performance improved. In some cases, we've seen like ridiculous numbers as like 300 times the performance of the previous implementation. You can test all that because one lemma I have is that if a vendor is talking about benchmarks, it's just benchmarking. I'm part of the vendor, so don't trust whatever numbers I give you. Run your own benchmarks. The thing is, this got improved. A bit of detail of what happened in queue paging. RabbitMQ has this cache of messages that I mentioned before, and it has a concept of messages that are either alphas, betas, or deltas. What is this? A message that is an alpha is a message that is only kept in memory, in this cache. A message that is a beta is a message where the message content was paged to disk, but not the position on the queue index. And a delta is a message where the position on the index, everything has been paged to disk. So delta is actually a struct that RabbitMQ keeps in memory with the first sequence ID that is on disk, the amount of messages that are paged completely to disk, plus the last sequence ID that is on disk. So messages, whenever they're published to RabbitMQ, whether they are persistent or not, they will be kept in this cache that Rabbit keeps as alphas. Then at some point they will be moved to betas, and at some point they will be moved into deltas if there are memory pressure to RabbitMQ. Like RabbitMQ detects it's running low on memory and it needs to get rid of these messages from RAM. So the paging algorithm will go through all these alphas and push them to the betas, which means writing to the index. Once this process finished and Rabbit still considers that messages need to be pushed to disk, those betas will be as well sent to the file system. So on the file system there is only, on memory we only keep track of these two sequence IDs, and we don't keep track of the messages anymore. Of course, we can load messages from this later if a consumer comes and decides to fetch those messages. What's interesting to know is that before all this alphas to betas, betas to delta thing was sending messages one by one, what we did, even after improving the flashing of the journal, was to make sure we send batches of messages to the file system and not just kind of one by one. The third problem that we discovered, because once we had the patient improved, the benchmark I talked before of sending 5,000 messages per second into RabbitMQ for an hour was able to last around 15 minutes without problems. But after 15 minutes, for some reason, RabbitMQ will start paging and paging, and in a wrong feedback loop of paging messages to disk. Then after 10-20 seconds, it will kind of recover and keep going, but immediately after the 10-20 seconds, we'll start again in this wrong feedback loop, recover, and so on. So, of course, there is something wrong going on. We have to find out what. The first thing I did was reproduce the problem presented by the user on the mailing list, and RabbitMQ has a tool called RabbitMQ CTL that lets you run commands against a broker. One of these commands is called reports, that can tell you many details about what RabbitMQ is doing with memory and so on. And one of the things that this command tells you is how many messages is RabbitMQ keeping on this cache. And when paging, RabbitMQ sets a target run count, which means by the current memory calculations, there should be as much as 1,000 messages in RAM, or 20,000, or 100,000, or whatever. When this wrong feedback loop started, which was around when there were around 10 million messages queued into a particular queue without consumers, the target run count was really low, was set to around 1,000 messages or even lower. So this was, of course, a problem because, as I told you before, in my machine I have 16 gigs of RAM. So there is a problem on why Rabbit is trying to keep paging and paging messages to disk. I started suspecting there was a memory leak somewhere, and using Recon, this library by the same author of Learn New Some Erlang, I was able to discover what was the part of the code that was causing a memory leak. The problem with Erlang binaries, is that if you send binaries across processes, sometimes Erlang is not able to garbage collect them because it doesn't know if they are being used or not. This is very well documented on a blog post written by the same author, by Fred Herbert, the author of Learn New Some Erlang. He also wrote Erlang in Anger, and he describes all this research he did on memory management in Erlang on that book, which was really helpful here to try to understand what was actually going on. So anyway, when I ran this tool, it was telling me that the way we were handling message IDs, which are binaries inside the queue index, was creating, in the moment where I was having this problem, I had around 3 million of these message IDs which were leaked, basically. So that's a lot. The problem was then that RabbitMQ, it was able to page to disk. It was doing it pretty fast because we improved the paging performance, but it was not able to reduce memory usage because of this particular leak. In Erlang, you can force garbage collection per process. In RabbitMQ, each queue is implemented using one Erlang process. So what we could do, which was quite easy at the end, was to force garbage collection after paging for a queue. With this change, we managed to run this particular benchmark of 5,000 messages per second for an hour without problems, and basically solving this issue that our user on the mailing list had. So what we changed was, to recap, to fix the way the journal entries were sent to the disk. We improved batching on the index to also allow for batching publishes. And we discovered this memory leak, and we fixed it basically to to be able to handle queues where consumers are offline. Of course, this can be a common case because a user may need to deploy new code and shut down all the consumers and restart them later again, or some AWS data center goes down, and in that particular data center, you had running your consumers and so on. So it's a very valid use case, and we are happy to say that according to our test, this seems to be solved. Of course, we welcome your feedback, and these improvements are already on versions 3.5.6 of RabbitMQ, so you can already test them and benefit from them. Next problem. From time to time, I track what happens on Stack Overflow from RabbitMQ. There are more people helping there, luckily. But I found a question from a user, which he was basically complaining that mirror queue synchronization was too slow. And then he wanted to disable it and see what could be done to get rid of this problem, because whenever a node was shown in the cluster, the queues will start to synchronize, and while they synchronize, they are blocked. They are not, these queues won't be accepting publishes and so on, so will result that your publishers get throttled down, the same with your consumers, etc. So yeah, this is something that, let's see what's going on, let's try to fix it. My test showed, again, my own machine, localhost, whatever, that's the best setup, actually a very optimistic setup to try synchronization of two brokers, because there is even no network traffic. So it's not realistic, but it's as fast as it will go, let's say. I tried pushing 1 million messages in Rabbit, and when I bring a new mirror online, it took 60 seconds to send these 1 million messages to the other broker, which I think, yeah, is really bad, that a user has to be waiting for a minute to get their queues synchronized. When I look at the implementation of the synchronizer, the thing that quickly came to mind when looking at the code was that, yeah, it's synchronizing one message at a time. Erlang is as fast as it can go, but I'm not saying Erlang needs a minute to process a million ops, but it, again, looping over 1 million entries and so on was quite slow. So the solution was, again, why not implement some kind of batch publishing at the queue level? So right now, queues implement just a publish function that whenever a channel publishes a message to a queue or to the exchange does the routing, the message is delivered to a queue and then published into the queue. Why not implement something that does this, but in batches? Because, again, once we know the message goes to a queue or a set of messages go to a queue, there is no further processing to be done for that particular message other than put those messages into the queue. In the case of synchronization of queues, we know exactly on which queue message will end up, so we can easily call batch publish instead of publish. The thing is, RabbitMQ has an API for baking queue implementations. You can implement your own queue in Rabbit as long as you follow this API. This API tells how to publish a message, how to hack a message, how to send a message to a consumer. If Rabbit is running out of memory, we call a callback in this queue implementation telling it to reduce memory usage. Each queue will know what to do in this case. In the case of the variable queue that you see on the screen, these queues will page messages to disk and so on. But the thing is not that simple, because we also support priority queues, we support mirror queue masters and mirror queue slaves. So implemented batch publishing wasn't as simple as I thought initially, because, yeah, as you know, in programming, estimates, they don't work. So in my case, I thought, okay, I should implement a batch publishing thing here and I'm done. No, I'm sorry, but you have to implement it for priority queues, for mirror queues, and so on. We did all that. And initial test, again, same use case, same setup. we managed to go down from a minute or from 60 seconds to around 6 seconds when batching messages in the synchronization. The thing is, in the new RabbitMQ, the 3.6.0 that should come out in November, we will have this as part of the broker. The batch size will be configurable. We cannot recommend a default size. Of course, Rabbit will come with a default size, which I don't remember right now what that size is. But this heavily depends on the size of your messages, the speed of the network, and so on. So maybe a 20,000 messages batch is good enough, or maybe it can be 50,000 or 100. I don't know. This can be all set up with the via configuration and even policies. So you can change it at runtime. If you see that the actual value you set is not the correct one, you can at runtime set a new batch. The thing that has to be very careful here is that the Erlang distribution, that is how Erlang nodes manage to contact each other, is pinging each node every 60 seconds, every 2 minutes, and so on, depends on your configuration. But if a node doesn't reply in that particular time frame, the node will be considered to be down. In the case of a RabbitMQ cluster, you will have a network partition if this happens. So if you set a batch that is too big, then it might happen that a node is transferring data, too much data to the other node in a way that it takes longer than this network tick time, as it's called, to send the messages from one broker to the other. So you can cause a network partition, even though there is no network partition at all. But yeah, that's a problem with how the Erlang distribution works. So again, don't put this value too high or too low. It's something that you need to see depending on your particular use case. Problem number 3. A user that comes from the telemetry industry using MQTT asked that, yeah, I have too many devices sending messages into Rabbit, but it can happen that consumers can be offline for a day or even more. What can we do? Something I knew from the paging performance when I was doing the paging bug, trying to solve that issue, is that a queue that has over or around 20 million messages, for example, will use over a gigabyte of RAM just to function that particular queue. So if a user needs to have, I don't know what kind of throughput during one day without consumers, at some point something will collapse. So is there a solution? What can we do to reduce memory usage in queues? The solution was to come with a concept of lazy queues. These queues are called lazy because they don't keep any messages in RAM. This in-memory message cache that I mentioned before is kind of disabled. Every message as it enters the broker and reaches the queue will be sent to the file system, whether the message is transient or not. They will be sent to the file system. And messages will be loaded in RAM in the same way that a default queue works, only when a consumer fetches a message from the queue. If no consumer fetch messages from the queue, then there won't be any messages on this particular cache. And of course, we have to implement lazy queues for all the backing queue implementation that I mentioned before. Something quite interesting is that whenever RabbitMQ fetches messages from the file system, it does it every 16K messages. So even if messages are loaded from the file system, this will try to keep the RAM consumption quite low. Initial tests show that the throughput of lazy queues with one publisher, one consumer was very similar to default queues when using persistent messages. If you are using transient messages, then default queues are double the speed of lazy queues. So you need to consider which one you can use or you want to use. Down there, you can see the link of the issue where this was reported, explained, implemented, and so on, if you want to dive into details. And the test, or some initial tests, again, this is benchmarking. Run your own test. Don't trust what I say here. I tried publishing 10 million messages of 1 kilobyte into both lazy queues and default queues. A lazy queue, if there are no consumers, it takes 1.5 megabyte of RAM, while the default queue goes up to 1.2 gigabyte of RAM. So you can see there is a huge difference between using one kind of queue or the other. And when the lazy queue has consumers, it uses, for this particular test, around 40 megabytes of RAM when consumers are active. Another thing I noticed is that messaging rate is more stable on lazy queues because there is basically no paging to disk, compared to default queues that at some point, if there are no consumers, they will have to page messages to disk. So, and the long run, the lazy queues were kind of faster than the default ones, but again, depends on your particular use case, message size, and so on, or how will you benefit from one or the other. The cool thing is that lazy queues are configured also by policies in Rabbit. Policies are configuration values that you can set at runtime. So you can have a default queue that is converted into a lazy queue that then later you set it back to a default queue and so on. When the queue is converted into a lazy queue, it will pause while it's paging all the messages to disk, and then it will keep functioning as normal. And if the queue goes from lazy queue to default one, whenever a consumer comes to fetch a message, a batch of 16,000 messages will be loaded into RAM, and the queue will continue functioning as a default queue with this cache I mentioned before active, and so on. So cool thing is you can switch from one or the other. Lazy queues are coming on RabbitMQ 3.6.0. We are still on QA process for this issue. So yeah, we hope it will be part of 3.6.0, but it's still not merged. Finally, other improvements that we done in Rabbit. We moved to RlangMQ. We are working together with Lloyd Hogging, SN, for who knows him by the Twitter name, or IRC name, I don't remember. And yeah, he's the author of Cowboy and many other libraries. That means we also move into Ranch and Cowboy for the TCP acceptor and for the management plugin, instead of using, I think we're moving away from Web Machine and just going into Cowboy and so on. Then we collaborate in some issues with folks from Erlang Solutions. One of the things they've been working is in improving the management UI performance. That is, whenever you list queues or exchanges and so on, and you have way too many entries to list, before RabbitMQ would crawl. Now this has been addressed and is way faster than what we had before. And the same for RabbitMQ CTL. Before, when you listed queues on the Rabbit CTL or exchanges and so on, it will first fetch all the data and build the output at once, and then you will see the output on the screen. Now, as soon as each entry is consumed, let's say, these are shown on the screen, so it's way faster than what we had before. Other improvements: we will have a pluggable hashing algorithm for passwords. Before, yeah, sorry, we were using MD5, and we already have support for SHA-256 and 512, and there will be other kinds of hashing for passwords. We will have a queue master location strategies. That means you will be able to tell RabbitMQ, create the master of the queue on the node that has less masters or something like that. There will be different strategies. I already mentioned the last two. In the future, this is post 3.6.0. After 3.6.0 is out, we will have a RAT-based queue mirroring implementation. We are quite advanced in the development of this. we are not using our own RAF library. We are using a library that is already open source on GitHub, implemented by a Russian company, as far as I know. We will also have RAF-based cluster formation, probably. We will rethink, not rethink, what RabbitMQ in order to allow easier extensions, plugins, and so on. That means, for example, right now, I implemented the delayed exchange plugin. People is asking to be able to see how many messages are being delayed and so on. It's currently not possible or not too easy, I would say, and to let RabbitMQ list those messages, for example. It would be nice that a plugin is able to say, these are the commands that my plugin also adds to RabbitMQ, and we want to try something around that area. And we are also toying with the idea of implementing a tool to recover data from disk. RabbitMQ crashed for whatever the reason. You're not able to start Rabbit, but you know in that folder on the file system you have these many messages and you want to recover them. We will have a tool that will be able to scan the file system and publish messages to another broker that you will be able to configure and so on. So that's it for me. Thank you very much. I let you with Mladen in case you have questions.
Thank you for that, Alvaro, and I'm sure everyone will join me in thanking you for a very inspired talk on the future of RabbitMQ. Now, we are in our traditional situation of having very little time left and a lot of questions to ask you. I would just say that if you're specifically interested, some of you in the audience, in monitoring your RabbitMQ system, then the technology I mentioned at the beginning, Wombat OAM, the Erlang monitoring and management technology, may be helpful. It has a RabbitMQ plugin that extracts very specific metrics that could be of use. So have a look at our website for that. But what we can commit to is, in terms of the Q&A session that follows now, we'll try and answer as many questions as we can, and we will answer them in the order they were received. You're welcome to still be posing questions, but any questions that are left unanswered, we will answer in writing after the webinar. So to move on to question number one straight away. So Alvaro, Jakub, one of our audience, is asking, do you have any plans to have full support for AMQP 1.0, as the current plugin is still listed as experimental only?
Yeah. So we list plugins as experimental because we need feedback from the community. We have had very little feedback from the community about AMQP 1.0. There might be many reasons for it. For example, there are not so many AMQP 1.0 clients. I mean, libraries using 1.0 to talk to brokers. So as long as that's the case, for us it's hard to move a plugin that is not too used by users into a fully supported version. We might do it in the future or not, I cannot say. What we base the current plugin, I'm pretty sure, is on what the AMQP 1.0 plugin is doing, and we run those tests against our tests. And of course, we have our own tests to run against this plugin. But yeah, if there is not enough feedback on our mailing list, we don't know if people actually want that, versus using 0.9.1, which is a widely deployed version of the protocol.
Thank you, Alvaro. That's fantastic. Now, moving straight on to the next question to try and answer as many as we can. Piotr is asking, what is the main difference between Erlang processes queues and RMQ? When should I use RMQ in an Erlang system?
What is RMQ? I assume that RMQ is RabbitMQ. I don't know.
Yeah, that's it. Yeah.
Okay, so it's completely different. RabbitMQ has a TCP listener that has a protocol. It's not only Erlang based. You can talk to RabbitMQ from many programming languages, as I said before, Java, PHP, whatever, .NET, Clojure, I don't know. And in the case of an Erlang process, it's only used from inside the Erlang virtual machine. It can be able to communicate between processes across nodes in a cluster, but you're still confined to Erlang. And of course, the implementation of a queue or a message mailbox in Erlang is quite different from the actual queue implementation of a RabbitMQ queue, with all these paging things I mentioned before, how to fetch messages, how to remove messages, and so on. So there are two completely different things, I would say. When to use one, when to use another, if you need to interface with the external world, I'm pretty sure it will be easier to have a Rabbit there than to have an Erlang app where you need to write the whole interface to the external world yourself.
Okay, thank you, Alvaro. Just to say thank you for everyone asking all the questions that are currently, flowing in. There's way too many for us to answer in the remaining time, but we'll try and do the best we can with the remaining couple of minutes. So moving on to the next question from Richard. So the question is, can the in-memory journal be turned off for certain queues in the case of those messages that have higher requirement for persistence than others? So
okay, so that a message is sent to the journal or the cache is completely unrelated to the message being persistent or not. If a message is persistent, that is, the user publishes the message as persistent, and the queue is durable, that is, you configure the queue to survive broker restarts, then that message will be immediately persisted to the file system. At the same time, if there is enough memory in RabbitMQ, the message might be kept on that particular cache I mentioned before, but persistent messages are sent to disk and they are persisted. If there is a replication, of course, the message will be replicated and so on. So the queue cache or in-memory cache for queues is not related to message persistence or not. It's related to trying to deliver messages as fast as possible to consumers, but yeah, it's not related to that. The journal can be, it cannot be disabled, but you can lower how many entries are in the journal at each time and things like that. But I think the question, if persistent messages go to this, they go straight away to this, so they are not kept in RAM.
Thank you, Alvaro. Moving straight on to the next question. This is an interesting one. So Jared is asking, in a logging solution where RabbitMQ is used to store events prior to indexing, with an average event size of 200 to 300 bytes, which of these values should I be modifying some of the defaults to increase my throughput? So would you like me to repeat that?
No, what values to modify on the configuration to increase throughput? We have a whole blog post explaining how credit flow works on RabbitMQ. The credit flow being configurable is a new thing, also in 3.5.6. And this blog post explained all the details on what to change or why it matters to change one setting or another. It's really too long to explain right now, but it's on the blog on RabbitMQ.com.
Thank you for that. Alvaro, next question from Zen. So for mirrored queues enabled in a cluster, are messages or payloads stored in a data store on each Rabbit node, or do they share one data store but keep a separate index?
No, messages, there is one data store per RabbitMQ node. So this means if you have a cluster, each mirror will keep a copy of the message.
Okay. Thank you for that. We'll move straight on to the next question from Johnny. So Johnny is asking, how do you use lazy queue when storing messages when client is offline? Is it something that you can set in the client API, or is this done using the RabbitMQ CTL?
Both. You can declare queues as being lazy. By default, queues work in the default behavior. So if you declare a queue without any arguments, or not setting this queue mode argument, the queue will work in a default mode. If you set it as a lazy queue, then it will work as a lazy queue, but will always be a lazy queue. There won't be a chance to change that because AMQP doesn't allow to modify the declare argument of exchanges, queues, and so on. So you can set it from the client, but it will be kind of permanent. But again, RabbitMQ also has an HTTP API, so you can do a curl request or whatever the client supports to set a policy and set a policy that this particular queue is lazy or default or whatnot, which is the same thing that can be achieved using RabbitMQ CTL. So policies can be set from the command line, from the web interface that Rabbit has, or via the HTTP API using curl. So again, the client can do it at qdeclare, but that's definitive, or it can do it dynamically by setting policies with HTTP API, command line, and so on.
Thank you, Alvaro. Now we are officially out of time, but because we've received so many questions, we'll really try and honor this session with at least 2 questions more. So we'll answer 2 further questions. The first question is from Alexei. Alexei is asking, is there a plan in place to create routing distribution over WAN, such as routing set on an exchange in one cluster to set routing on a correlated exchange on a remote cluster?
I'm not sure I understand the question.
So the question, in short, is there a plan to create routing distribution over WAN, so wide area network?
I don't think we have a plan for that, and the closer we have is federated exchanges, which do routing across one. Yeah.
And finally, we really have time only for a single further questions. Are there any options in terms of fetching a particular message from the queue using, say, a correlation ID or a message ID?
No. The queues inside RabbitMQ, the queue is implemented using a queue data structure that supports inserting an item or at the back of the queue and removing the front item from the queue. To support this kind of use case, it will be a linear scan over the queue, possibly hitting the file system many times for each if the messages were paged or not. So yeah, it's not doable right now. I mean, it's doable, of course, but too slow.
Thank you, Alvaro, and apologies to everyone who's asked the many, many questions we received. We have run over the time scheduled for the webinar. So in closing off, I'm sure that, again, all of you will join me in thanking Alvaro for an inspiring talk on RabbitMQ. Many thanks to our audience who has joined the webinar in such big numbers. Now, please join us again for our next monthly webinar, which will be publicized shortly. Just to say that following today, we will send you a short survey to make sure that we capture your feedback of today's webinar. Please also note that the recording of the webinar and the complete presentation that was shared today will become available for you to collect on the Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you all once again, and we look forward to seeing you on our next webinar.